is Simpson rule? Simpson rule is a numerical technique used to approximate the definite integral of function. Instead of requiring an exact formula, it estimates the area under a curve by fitting parabolic arc between points. This allows the method to follow the curve moves smoothly and accurately than straight line methods such as the trapezoidal rule. It is especially useful when the function is complex or when analytical solution is not practical. Why we use Simpson rule? Because it's simple and efficient to apply for many real-world functions. Second, it produces highly accurate results for smooth and continuous curve. Besides, Simpson rule can help solve integrals that are difficult or impossible to compute analytically. Also, it commonly used in engineering, physics, computer science, and applied mathematics.
The theory behind Simpson rule relies on fitting a polynomial interpolant to the function value at equally spaced points. Simpson 1/3 rules approximate segments of the function using quadratic polynomial parabolas. It requires 3 points, the two endpoints and a midpoint. To define each parabolic arc, meaning to the total number of side intervals n must be an even number. Simpson 3/8 rules, also known as Simpson's second rules, is used cubic polynomial third order to approximate the curve. This vision required 4 points per segment, and the total number of side intervals must be a multiplier of 3. Number codes formula. Boost rule are part of the Newton-Cotes family of formula, which integrate an interpolating polynomial through equally spaced points.
Now, I will explain the formula for Simpson 1/3 rule. First, this is the expression represent the definite integral of the function f of x from a to b. Next, h represents the step size. It is calculated as b minus a divided by n, where n must be an even number and cannot be an odd number. The Simpson 1/3 rule formula is given as h/3 multiplied by the sum of the function values. The first and the last terms are multiplied by 1, and the odd index term are multiplied by 4, and the even index term are multiplied by 2. The coefficient pattern follows 1, 4, 2, 4, 2, and so on, ending with 4 and 1. This formula is used to approximate the value of a definite integral. Next, you will see the sample question and the answer.
As you can see, this is the example given for Simpson's 1/3 rule. Given that h is equal to 1, and the table for x and fx is also given, so you can note down f0 to f4 starting from the first x. The question is to integrate from 2 to 6 of f with respect to x. The formula given is h/3 times with f0 plus f4 and then plus f times the odd number of fx, which is for this question f1 and f3, and then plus with 2 times even number of fx, which is for this question is f2. And then you can just insert the info that you have from the question and then you get the answer. That's it.
Simpson rule 3/8 is used to estimate the value of a definite integral, especially when the exact integration is difficult or impossible to calculate analytically. It helps us find the area under a curve by using a smooth curve approximation instead of straight line, which improves accuracy. First, I will explain the workflow for Simpson rule 3/8. We begin by identifying the lower limit A and the upper limit B, then the interval from A to B is divided into 3 equal subintervals. The width of each subinterval is called h, and it is calculated by b minus a divided by 3. Next, we determine the x value, x0 at a, x1 at a plus h, x2 at a plus 2h, and x3 at b. After that, we calculate the function value to each of these points. These values are then substituted into the Simpson rule 3/8 formula. In this formula, the first and last value are add-ons, while the two middle values are multiplied by 3. After simplifying the expression, we obtain approximate value of the area under the curve. Now, I will explain the difference between Simpson rule 3/8 and Simpson rule 1/3. Simpson rule 3/8 divide the interval into 3 subintervals and use 4 points, while Simpson rule 1/3 divides the interval into 2 subintervals and use 3 points. In the formula, Simpson rule 3/8 follow the coefficient pattern 1331, whereas Simpson rule 1/3 follows the pattern 141. Another important difference in the condition of use, Simpson rule 3/8 requires the number of subintervals to be a multiple of 3, while Simpson rule 1/3 requires the number of subintervals to be an even number. In conclusion, Simpson rule 3/8 is used when the interval can be divided into 3 equal parts and provide a reliable and accurate method of approximating defined integral.
Okay, so next I will explain an example of using Simpson's 3/8 rule to estimate the value of the integral from 0 to 3 of the functions x cubed plus 1 with the number of subintervals n equal to 3. The first step is to find the value of h, which represents the width of each subinterval. The formula for h is b minus a divided by n. Therefore, h equals 3 minus 0 divided by 3, which gives h equals to 1. Step 2. We calculate the values of the function fx equals x cubed plus 1. When x is 0, fx is 1. When x is 1, fx is 2. When x is 2, fx is 9. And when x is 3, fx is 28. Then, we apply the Simpson's 3/8 rule formula, which is 3h/8 multiplied by f of x0 plus 3 times f of x1 plus 3 times f of x2 plus f of x3. Substituting the values, we got 3/8 multiplied by 1 plus 3 times 2 plus 3 times 9 plus 28. The total value inside the bracket is 62.